Hi, welcome back to AT Math. Today, 2-4, solving equations with variables on both sides. First, let's go back and see what we've learned. If you remember from this example, if you have 3x plus 1 equals 16, step 1 is to get rid of the plus 1, and the opposite of plus 1 is minus 1. Therefore, you minus 1 on this side and minus 1 on this side. By doing so, this gets rid of the plus 1, so you just have 3x, and over here you just have 15. Then the next step is to get rid of the times 3, because x times 3. The opposite of times 3 is divide by 3. Divide 3 on one side, you have to divide 3 on the other. Therefore, these 3's go away, leaving the x. 15 divided by 3 makes 5. So your answer is x equals 5. You can also know this by plugging it back in, because 3 times 5 makes 15, plus 1 does make 16, so you know it works. Now, to start our section today, I want to give you a quick story about an old movie named Highlander. Highlander was a movie where, among all the humans, were a very small group of immortals, and these people would live on forever. However, they would live on forever, but when they would run into another immortal, they would have to actually stop whatever they were doing and go into a sword combat. And the winner was the one who slayed the other person, and the winner would actually draw the energies of that slain person. And every time this happened, the winner of that particular sword battle would grow stronger and stronger until there could only be one. That was the whole theme of the movie, was that these people were swirling closer and closer until there's only one immortal left. Well, the story of this translates like this. In this case, you'll see x's on both sides of the equation, and you can't have a finished product with an x on both sides. You need to get rid of one of the x's. Now, the key to this is it really doesn't matter which x you get rid of. Either one will work. However, I find it a lot easier to get rid of the smaller x than the larger one. So in this case here, if you take a look, 5x plus 20 equals 3x plus 30. I need to get rid of the 5x or the 3x. I'll say again, it doesn't make a difference which one I get rid of, but I find it easier to get rid of the smaller one. So I'm going to get rid of this 3x. Well, the opposite of positive 3x is minus 3x. If you minus 3x on one side, you have to minus 3x on the other. So, by minusing 3x, this goes away. 0x, remember, just is 0. And 5x minus 3x makes 2x. So now, my equation is 2x plus 20 equals 30. From there, I should know what to do. I'll just minus 20 to both sides over here and over here. And that leaves 2x, and that leaves 10. So 2x equals 10. Instead of times 2, I'll divide by 2, and I get x equals 5. If you're not sure, just plug it in. 5 times 5 is 25, plus 20 makes 45. 3 times 5 is 15, plus 30 also makes 45. But I want to prove to you that it doesn't matter, and here's how. I'm going to go ahead and recopy this. And with just the pen I have, this electronic pen, I'll do it the other way. Suppose I subtracted 5x instead of the 3x. Would I get the same result? Let's take a look. These cancel, leaves 20. Over here I have negative 2x plus 30. Then to get negative 2x by itself, instead of plus 30, I'm going to minus 30. And that leaves negative 10. Then instead of times negative 2, I'm going to divide by negative 2. And negative 10 divided by negative 2 actually equals 5 again. So a little more work, but notice how x still equals 5 either way. This shows you that there is no difference with how you do it. Go ahead and you try it this time, see how you do. Okay, let's take a look. You probably minus 8x from both sides, as I did here. 13 minus 8x, and then instead of plus 2, you minus 2 to both sides. So you got 20 equals 5x, and then divide by 5. Hopefully you got x equals 4. Plug it in, you'll see that it works for both sides. Now subtraction works the same way. In other words, you have 8x, you minus 8x to both sides, as you see here. So this goes away, and this is 5x. You go ahead and minus 3 to both sides, but negative 22 minus 3 more makes negative 25. Divide by 5. In other words, you can have a negative number and it's still the same value. It still works the same. Because if you plugged it in, Negative 5 times 8 is negative 40. Negative 40 minus 22 is negative 66. And over here, negative 5 times 13 is negative 65, but plus 3 makes negative 62 as well. So either way it works. You try, go ahead. Let's see how you did. The nice thing is you just added 8x to both sides. That made it easy. So just 21x equals 42. Divide by 21, x equals 2. Sometimes you have to simplify first, and what I mean by that is if you notice here I have a 2 on the outside. Alright, well I need to multiply 2 to both of these guys first. Okay. Oh, and by the way, you can follow on page 101 if you like. 2 times y is 2y, 2 times 6 is 12, equals 3y. Now instead of plus 2y, we're going to minus 2y to this side and then this side. So I'm going to go ahead and get rid of this guy. So 12 equals 1y. Or y equals 12, whichever is easier. You plug it back in, you will find 12 plus 6 is 18, times 2 is 36, and 3 times 12 is also 36. So it works. You try, go ahead. Alright, let's see how you did. Hopefully you took 5 times to both of them. 5 times x and 5 times negative 20 equals 6x. 5x minus 20 equals 6x. Hopefully you minus 5x to both sides. Negative 20 equals 1x, or just x equals, wait a minute, that should not be 21, that should be 20. There we go, because when I add 20 to both sides, add minus 5x to both sides, I get 1, yeah. So let's plug negative 20 in to be sure. Negative 20 minus 4 makes negative 24, and negative 24 times 5, let's see, I get negative 120, and 6 times negative 20 is also negative 120, so I'm okay. Again, a little more complex. Page 101 can help you if you have the textbook open. This guy here, the first thing I'm going to do, I'm going to times negative 2 to 1 and negative 2 to b. Now be careful here. This minus 2, you might say, wait a minute, isn't this negative 2 minus 2? Yeah, but because the negative is attached to the 2, you have to take negative 2 times both of these guys, and that's where it gets a little choppy. So I'm going to take negative 2 times 1 and negative 2 times negative b, but by doing so, this negative goes away. In other words, if the number ends up positive, it's a positive. If it's a negative, it's a negative. So negative 2 times 1 does make negative 2, so negative 2 or minus 2 stays the same. And negative 2 times negative b makes positive 2b. Yeah. Negative 2 minus 2 more makes negative 4, and then 2b comes down. Over here, I'm just going to combine the negative 5 plus 2b to make a negative 3b. So after all that work, I now have 3 minus 3b plus negative 4 plus 2b. In my mind, negative 3b is smaller than 2b, so I'm just going to get rid of the minus 3b. How? By adding 3b. Add 3b to one side, add 3b to the other. You notice here I did add 3b to both, which cancels it, leaves just the 3. Add 3b over here, I get 5b. Now, to get 5b by itself, instead of minus 4, I'm going to add 4 to both sides. And then instead of times 5, I'm going to divide by 5. Now, you have 7/5 as your answer. Now, you're like, wait a minute, can 7/5 be right? Well, you can either times them all by 7/5 or 1.4. But if you do that, 5 times 1.4 is 7. So 3 minus 7 plus 2 times 1.4 is 2.8. And over here, negative 2 minus 2 times 1 minus 1.4 is going to be negative 0.4. And 2 times negative 0.4 is going to be negative 0.8. So let's add these up. 3 minus 7 plus 2.8 to make it easier. I'm going to take 3 plus 2.8 and get 5.8. However, that's minus 7, which is going to give me a total of, let's say, negative 1.2. And over here, I have negative 2. And then negative 2 times negative 0.4, if you will, is going to be plus 0.8. And negative 2 plus 0.8 is also negative 1.2. Granted, double checking is a lot of work, but doing that makes me understand that I know my answer was correct. You try. Go ahead. Let's see how you did. So when you went ahead and you took a half times b, which is half b, and 6 times a half, because why did you do that? You had to take a half times both of these guys. So half times b is half b, and half times 6 is 3. That's the beginning. Now again, I can get rid of either. I think it's easier to get rid of the half. So instead of plus a half, I'm going to minus a half. Minus a half to one side, minus a half to the other. So I'm going to get 2 over 2b, or just 1b. So 3 equals 1b minus 1. And instead of minus 1, plus 1 to both sides. 3 plus 1 is 4. And b equals 4. That's your answer. Don't believe me? Plug it in. 4 plus 6 is 10, times a half is 5. Half times 3 halves times 4, well, 4 divided by 2 is 2, times 3 is 6. Minus 1 is also 5. That's how you know it works. Give it another try. Go ahead. Let's see how you did. Hopefully you first combined 15 and minus 9 to make 6. You times 2 to both sides here to get 2x plus 4. Then you went ahead and minus 2x to both sides, which gave you 1x plus 6 equals 4. Then you minus 6 to both sides and got x equals negative 2. And if you plugged it in, hopefully you found it. Now, with variables, it is possible to have multiple answers or none at all. What I mean by that is if we combine these two here, take 1x minus 6x, which makes negative 5x, and the plus 4 is here. And over here you have negative 5x, and 6 minus 2 is 4. Notice how these are exactly the same. And when you add 5x to both sides to get rid of them, notice how both variables go away. When that happens, notice how you just have 4 equals 4. Since 4 will always equal 4, the trick is that any value would do. In other words, any variable. So there is no one variable solution. In this case, because 4 will always equal 4, x has infinite solutions. Now, if we did a different value for x, and I just picked a couple to plug in, I'm not going to make you follow the whole thing, but I simply plugged in a couple numbers from the problem from the preceding page. So I plugged in a 2 here, and I plugged in a 3 here. When I plugged in the 2, and I'll save you all the time of going through it all, when you do all the math, it becomes negative 6 equals negative 6. When I plug in a 3, negative 11 equals negative 11. And the reason for that is no matter what x you pick, the answer will always equal each other. So therefore, there's all real solutions or infinite solutions. I'll accept either on your answer. And that's because you had a scenario where both equations were the same once you simplify them and saw it. On the other hand, if you have something like this, negative 8x plus 6 plus 9x equals negative 17 plus x, notice how when I combine these, negative 8x and 9x, I get 1x. But here I have 1x plus 6, and over here I have negative 17 plus 1x. Well, when I subtract the 1x to get rid of it on one side, it also gets rid of it on the other, but 6 cannot equal negative 17. And because there's no variable left, in this case, 6 will never equal negative 17, therefore, there is no solution. So since they cannot work, there is no value for x that can make it work, therefore there is no solution. So for an answer like this, you'd put no solution. How can you tell which is which? When the variables are equal on both sides, then check the non-x. Same variable, same non-variable. In other words, same x, same non-x, infinite. Same variable, different non-variable, no solution. Can't work. Finally, if you happen to have your textbook, read page 102, example 4. It says here $36 plus 3 cents per minute is the same as 0.06 per minute. So what you'd have is you want to know when they will meet. If you have to pay 36 cents up front and pay 3 more cents a minute versus someone that pays 6 cents a minute, that's when you want to compare that. Where would you ever use this in real life? Well, your phone, believe it or not, at one point you were charged per minute years ago. And nowadays you might have to pay per text, or you might have unlimited text, but you have to weigh that. How much will unlimited text cost me? And will that unlimited text be worth more than if I text it individually? If you text 2 or 3 times a month, which if you're teens, I know you text about 2 or 3 times a minute, but my point is that if you text it 2 or 3 times a month and it costs, let's say, a dime each, okay, that's 30 cents. And if you pay $5 a month for unlimited texting, it ain't worth it. However, if you text, let's say, 1,000 times, and each text would have been 10 cents, that's worth $100 to you, and you want to buy the unlimited texting. So anyway, so here you have a case where it's 36 cents plus 3 cents a minute, or here 6 cents a minute, find out where they equal out at. So I have two variables, I have to get rid of one of them. So instead of plus 0.03, I'm going to minus 0.03. And by the way, if it helps you, if this completely throws you off, times everything by 100 to begin with and get 36 plus 3x equals 6x if you need. Either way is fine. Anyway, minus 0.03x minus 0.03x, these cancel, leaving 0.03x and leaving this as 0.36. And then instead of times 0.03, we're going to divide 0.03 to this side and then this side. Divide them both, and I get x equals 12. And that's it. Thanks again. Talk to you later. Bye.